To begin our unit on data, let's just have a look at the meanings of some words that we'll need to use in this topic. So we've seen quite a lot of these before when we studied probability and probability distributions, so it should be reasonably familiar. We've already discussed a random experiment. That's just any experiment that has more than one outcome. And we compared this last time to a deterministic experiment, which is one that only has one outcome and where we know what's going to happen. Now, a random variable is the outcome of any random experiment, and we usually denote it with this capital X. Now, capital X can take on a number of different values depending on what the experiment would be. So the values that X can take are the possible outcomes. So for example, if I'm going to roll a die and X is the outcome of that random experiment, then X could be equal to 1, 2, 3, 4, 5 or 6. Those are the options. If I'm going to flip a coin, X could take the value of heads or tails. Scores. Now when we run an experiment lots of times, the outcomes become called scores, and that sort of makes a little bit more sense. In a moment I'll give you an example that should help with that. Now if you have a whole list of scores, and we say it's finite because we need an actual list that ends somewhere, we call that a sample. And then the frequency of an outcome is just the number of times that it happens. So to give you an example here, let's just say we asked everybody in the class to roll a die, say 10 times, and see how many sixes they get. What your random variable is depends a lot on how you word your experiment. If I just said toss a die and see what you get, then the random variable could be 1, 2, 3, 4, 5 or 6. But if I say toss a die 10 times and record how many sixes you got, what are the possibilities now? Well, the random variable is that you might have got no sixes, you might have got 1, 2, 3, 4, 5, 6, you might have even got 10 sixes. It's unlikely, but possible. So the framing of the question or the experiment really dictates what values the random variable can have. Now, when you run your experiment and you've rolled your die 10 times, you'll have a score. You'll say, I got 2 sixes, or I got 4 sixes, or however many you got. That's your score when you ran the experiment. But because we're running it lots of times, we can have a whole list of scores. And if everybody in the class tells me how many sixes they got, I've got a whole heap of numbers. Now, I'd be interested in finding out how common it was to get no sixes, or 1 6, or 2, or 3, so that then I can work out how common it might be to get those same outcomes again next time. So we can put all of this into what's called a frequency table, or a cumulative frequency table. Let's have a look at how it works. Our experiment says 20 students roll a die 6 times and record the number of sixes. So that number of sixes that they got is their score. The possible scores that someone could have would be anything between 0 and 10. Obviously, it's not very likely that somebody's going to get all 10 sixes. And if I did a bit of a survey of the class, I've just made up some results here that perhaps we might have got. Now, why do we use tallies? Well, because when we're collecting data, it can be handy just to make a tally. I could go around the class, and as each person tells me their score, I can just add them up here as a tally. My next column then is the frequency. How often did it happen in this class of 20 students that you get a score of no sixes? Well, it happened twice. Getting 1 6 happened 6 times, 7 people got 2 sixes, 3 people got 3 sixes, and only 1 person each got 4 or 5 sixes, and none of these other scores occurred. So you could put zeros in there as placeholders if you want to. All right, cumulative frequency. This word cumulative means adding up. So the cumulative frequency, and I've got a definition down the bottom here that you should write down, says cumulative frequency is the number of scores less than or equal to a given score. So when we're saying what's the cumulative frequency of 0, that's a way of saying how many people got 0 or less. Well, obviously you can't get less than 0, so we start with 2. It's exactly the same number. How many people got 1 or less? Well, it's these 6 people who got 1 plus those 2, so we have 8. And each time we're just adding this next number. How many people got 2 or less? 7 plus 6 plus 2. So obviously we need to do the 8 plus the 7, and we can add them up. Now we need to add these 3 people, this 1 person, and this 1 person. So the cumulative frequency tells a slightly different story. It just shows how many people had a certain score or less. And in some instances, that data can be quite useful. We can also put all of this into a table, of course, and graph it. So when we're working with data, we're really working with random variables, and they can take 2 forms. They could be numeric, meaning they're made up of a number, or they could be categorical. For example, if I do a survey of the colour of cars in the car park outside, I'll come up with things like white, silver, blue, and these aren't numbers. Whereas if I do a survey of shoe size in the classroom, or if I measure everybody's heights, I'm going to come up with answers that are numbers. Now, when they're numbers, we generally divide them into discrete numbers or continuous numbers. And one simple way of deciding which one you have is to say, are we working with things that can be counted? 1, 2, 3, 4. How many siblings do you have? Questions like that. Or things that can be measured, like how tall are you? Which really comes down to, well, how good is your measuring instrument and how much do you want to round it off to? Now, sometimes it can be hard to decide whether your data is numeric or categorical. For instance, it might be that you're looking at the age of people in a study and you're saying they're in year 7, year 8, year 9. Now here, those names have got numbers in them, so it's easy to think that they're numeric, and perhaps we're counting the number of years they've been at school. That's a good argument. But you could also argue that they're categories of people, groups of people, and that we've just randomly named them year 7. We could call them the blue group or the yellow group. So deciding which one you have can be a little difficult, but mostly we need to know that when you're working with numbers where the number actually is meaningful, you're probably over here.